Hey, PHY 4451, Professor Dustin here. I'm just going to do a quick video introducing you to the lab that we're going to do on Thursday. Don't have a lot to do because actually the lab is relatively straightforward, but I do want to give you some context and tell you, and there's going to be a pre-lab assignment as well, so I want to explain this. So first, I'm just over on our Canvas page. Behr Freefall is the lab that we're going to do. That's the name of the apparatus. Probably named after a guy named Behr, I'm not sure. So here's the intro lecture. I'll put a link there once it's done. So watch that first. So I hope you watch that about how to write a scientific paper. Here's the link out to that description of writing scientific papers by the Nature Journal. There's a template for these labs, which I'll just want to show you real quick. You don't have to use this template, but it is a nice way to start. Title, name, abstract, and then the intro, method, results, conclusion. So here's the body, here's the introduction, abstract, and conclusion. So it's on Google Docs, so maybe it's not the way you want to do it, but it gives you a sense of like kind of what I'm looking for. That's the lab template. I also included a few examples of introductions written by me. So these are from my actual papers that I've written over the years. Because introductions should basically be readable by most people. Now, mine are highly technical, so I don't expect you to read them and understand them. But you can see the structure where I give like background information about the topic I'm going to write about, and then primary goal of this paper, what I'm going to do, and then here is basically the object, which is like just describing what is in the rest of the paper. And you can see they all follow that pattern. I didn't learn it from Nature, but that Nature article really describes the process quite well. Background, what I'm going to do, why I'm going to do it, and then this one's a little bit longer because I have like a section specifically devoted to the topic, but you can also see that there's a context here, right, where I say what I'm going to do in each section. So anyway, you can check that out if you want more examples of what the introduction looks like. Those are totally optional. And then here's the pre-lab assignment. Before talking about the pre-lab, and we just go through the lab a little bit. I think I can do that just by looking at the lab manual, which is here. So there's that apparatus. This is also called a spark timer. So what this thing does is you put a weight at the top and drop it, and a spark goes between like two connectors here, and a piece of paper is stripped through the spark timer as the weight falls, and the sparks every like 1/60th of a second or 1/30th of a second or something, and so you get a bunch of dots on the spark paper as the thing falls. So all those dots can be used to find the acceleration due to gravity, and that's actually what we're going to find. So we're going to find the value g and try to get some estimates of the uncertainty on g. After you run the paper through, it basically looks like this. So here's the top of the paper, and you get a bunch of dots, which are sparks, and you can see the sparks are further and further apart as the thing accelerates downwards in free fall. So then you can use that paper to figure out how fast the thing is moving, find the velocity as a function of time, then find the acceleration, which is what we're interested in. So basically what you want to do to prepare for the lab and prepare for the pre-lab is to read this document. Notice the note that I made there, which is to skip the stuff about the apparatus, right? So the procedure is useful, but this part in the middle about the apparatus is probably not all that useful because it's specifically like the technical details of how the thing works. It's not really necessary for us to know that. What the description I gave you of the spark jumping every 1/60th of a second, that's all you really need to write the introduction. And then you can read about the experiment and what you're expected to do. There's an example table. So basically what you're going to be doing is creating this table. So here we have the total distance traveled over each interval of time. You're going to measure that on the spark tape. So you're going to make a table like this, and then you're going to make some plots like this. So this is the position as a function of time as the thing falls, and here's a velocity as a function of time. The position is what you just get from your raw data. Then your job is to construct this velocity as a function of time. Now, the goal is to find the acceleration due to gravity. So there's a number of different ways you can do it, and it's kind of up to you to decide what the best way is. I could talk you through some of that, but remember some stuff like the formula. So do we have a position as a function of time formula here? No, we only have the velocity as a function of time. So do remember that, like, if you can find the velocity as a function of time, the slope of that line would be the gravitational acceleration. Done. Now, finding the slope of this line can be a matter of like manually finding the average velocity between each of these points and plotting it, or you could maybe go to Excel and fit a line to this and pull the acceleration of that. There's a number of different ways you could do it, and I can talk you through some of that. But the job is going to be take the data, find the position as a function of time, get the acceleration from that. So certainly you're going to want to create a table like this, but how you do the analysis is going to kind of be up to you. Doing the lab literally takes 5 minutes. Like actually running the experiment, dropping this thing takes 5 minutes. So you're not going to spend much time doing that. A lot of the time is going to be analyzing the data. And then I also have a set of questions at the end. So remember, the questions are what are going to replace our conclusion. So you're going to have all the 4 sections of the lab that I talked about in the original video. And then at the end for the conclusion, you can write a sort of conclusion if you want, but what you're going to be graded on is how you answer these questions. And this is going to be typical for all our labs. Instead of a conclusion, we'll have questions like this. Okay, so what else do I want to say here before going on? I think that's about it. You want to read this, before the lab, you probably want to read it kind of carefully, but you also don't need to kill yourself. You need to read it enough so that you think you can write a draft introduction to the lab, because that is what your pre-lab assignment actually is. So if I go down to clicking on the pre-lab assignment, read the lab procedures, write a draft introduction to the lab. So draft means I don't really want like misspellings or like terrible grammar and stuff like that, but it can be totally imperfect. It can be kind of stream of consciousness. It can not sound great. That's okay. Make a pass at writing it, maybe look at it one more time and then turn it in. That's the kind of draft I'm thinking about. If you're having trouble starting, right, remember you're writing an introduction. So I just talked about that in the previous video. It has 4 parts: context, need, task, and object. If you're having trouble getting started on the introduction like this, think of, I need to write a paragraph about each one of these things. Go to the video I just made. What is the context? Write about it. What is the need? Write a paragraph. Task, write a paragraph. Object, write a paragraph. That will basically be okay. And what I'm going to do during the lab is actually grade these to give you a sense. And I mostly grade, but really I'm going to comment on them to tell you if you're in the right direction or what kind of things need to be changed. It's worth 3 points. If it's basically complete and basically fine, it's 3. If you're like needing a fair amount of work, it's a 2. If it's half done, it's a 1. And if you don't turn it in, it's a 0. So it's going to be a relatively relaxed grading scheme. Okay, I think that's it. So the pre-lab assignment will be due on Thursday when you come to class, so make sure you get it done. I don't think it should take you forever, and also it should basically be your introduction, a draft of your introduction for the lab. So I also think it's going to reduce the amount of time you have to take after the lab to write. You can take the exact introduction, change some of the stuff based on my comments, and I think that will be enough for the introduction. So I hope that it is not a huge amount more work. I think it's just distributing the work around a little bit as before the lab and after the lab. Okay, cool. And as always, I'm always around for any questions, so please reach out. I think that's all I really have to say. Whenever you watch this video, I hope your weekend has been good. Thank you for letting me do this video instead of class on Monday. Remember that we have canceled class before Thanksgiving to account for this. And I will see you on Thursday. All right, take it easy, guys.